talking about the off-site backup appliance. So first of all, we have a whole load of shared files, as everybody knows, on Ephesus. We want to keep a copy of the files off-site so that they're safe from any type of issues. We want something that's really easy to use, and to be honest, here the external network is a little bit unreliable. So we don't want to have to depend on the external network. And we want something that's robust. We want something that, even if it goes wrong, is not going to cause Ephesus to have a problem, because obviously people depend on Ephesus. So the initial proposed solution was that we should buy two external USB 5 terabyte disks, which we keep off-site, and then we have a backup appliance in the makerspace that makes it simple to then do the backup. The proposal was that we build that using a Raspberry Pi. We have something that can detect the disk plug-in, that can start the incremental backup, and we have some indicators to show what's going on with it, where it is. Okay, so I put together, okay, this is the basic, this is a picture, just in case you can't imagine what that was. Ephesus is our shared drive, and every night it backs up from the two of the partitions, the internal partition and the large file partition. It backs up into the backup partition. So we've got a backup there anyway, but of course that's on site. So if the building burns down, we're screwed. Athens is the proposed name for the backup appliance. When you bring a disk in and plug it in, that causes the incremental backup to go. Once the incremental backup is finished, you can then unplug that and take it offsite. For those that didn't understand the thing. Okay, so I put together a project document. In Prince it would be a PID, but basically a 6-page document explaining what the project is, what it's going to do, how much it's going to cost, how the basic thing's going to work. And I took that along to the committee in February, and on the 6th of February they approved me to actually make the thing. In fact, they suggested some improvements, which I later on incorporated. So these are the bits that I used to build the thing. So we had a Raspberry Pi 3 already. I bought this powered USB hub. The reason is the Raspberry Pi 3 is not powerful enough to power these big hard disks, and so you need extra power. So I bought a powered USB hub. I also grabbed these components. Some of them I grabbed out of the components box in the electronics area. The header I had lying around anyway. And then finally we got the SD card, which has got the operating system and stuff on it. Okay, so you'll notice in here there's only one power plug. So how are we going to power the Raspberry Pi? Well, the answer is we power the mains. The mains powers the USB hub. The USB hub powers the Raspberry Pi, and the Raspberry Pi then controls the USB ports on the USB hub. So we can bolt these three bits together. We only have one mains plug, which is a great benefit. Okay. So how's the system work? Well, the system basically has 5 states. If the disks are absent, we're in this top state, and then you plug a disk in, and that sets us into this unmounted state. As soon as it notices the disk has been plugged in, it mounts the disk, then it kicks the backup off, and when the backup finishes, it unmounts the disk and it puts it back up into the absent state. Okay, so everything from unmounted downwards, this stuff in dark blue, that's when the process is running. So we need some indicator that says when the process is running. The other thing you'll notice is that in order to go around the complete cycle, you need to unplug the USB drive. In other words, if you leave a USB drive plugged in forever, it's not going to run another backup because it's not going to think that first backup has really been finished. So we have two different indicators. The first is the running light, which is in green. This just indicates that the process is running at the moment. But also, things go wrong. So there's also an error light, which is in red, that when if there's an error encountered, it'll light the error light. Again, this is important because the green running light goes dark when the process is finished. The red error light stays on even after the process is finished and stays on until the disk is unplugged. So that means the person who's plugged the disk in has a chance to see there's an error before they take the disk away. Okay, and so how are we going to do this? The Raspberry Pi has this 40-pin header. And what we're going to do is we're going to use these 3 pins here. That's Gen 1 and Gen 4 and a ground in between to run our 2 LEDs. Nice simple circuit here. Just goes straight from the pin through a resistor to an LED to ground. And then this is being controlled. There's a C library under Linux, on the Raspberry Pi, which allows you to control the GPIO pins. It's called WiringPi, and for example, to run these two, you basically, there's a nice simple setup. You can see we set the pins into output mode, we set them high, we set them low, whatever. Yeah? And so I wrote a little program called set LED. And here's the program. If you say set LED green on, the green light comes on, red on, the red light comes on, red off, the red light goes off, green off, the green light goes off. As simple as you can make it. Okay, so this is basically what the software needs to do, what the service needs to do. It needs to detect if the device is available. If the device is available, turn on the green LED, mount the disk, run the incremental backup, unmount the disk, turn the green light off. And then wait until the disk is unplugged. And once the disk is unplugged, that triggers us to go round the loop again, and also we can clear the error at that point. So these steps in cyan, you can see they're just written in sort of English. If we look at a real configuration, this is the USB device that I've got is Dev SDA1. The mount point, that's where to find the disk, is backup, and the remote source is getting it from user ad Ephesus backup disk. Real name's not being used in this case, of course. But of course we need to translate those into statements for the cyan. Is the USB device available? That's basically, does the SDA1 device exist or not? The Raspberry Pi kernel I've got is got auto detects when things are plugged in and automatically sets up the mount points. Okay, then the mount is a nice simple mount. The backup, nice simple backup, and the unmount is there with you've got the unmount. So that's basically what we needed to do for the software, except of course we needed to make it a little bit more complicated than that. I needed to add a verbose mode so that I could run things and it would print out on the terminal if it was in verbose mode so I could see what is going on. I needed to add a whole load of startup checks, so it checks to make sure that all of the necessary executables are available, make sure that there isn't already a device mounted on /backup, and so on and so forth, just to check that everything looks like it's okay. We need to be able to handle the errors, so we've got these various commands we're using. We need to be able to detect when they're causing errors, when they're not working. And then we need to report start, stop times, the processing and all of that stuff. And then finally, all of the commands are being compiled as absolute paths so that you can't spoof the process. Not that anybody's going to be able to log into the appliance anyway. Okay. Then finally, what I did was I installed the Apache server, the Apache web server, and I configured it so that it would show all the logs in reverse order, of course, so the most recent ones first, show with this little green thumb, show that the service is currently running. And if you have a look at this address here, you'll be able to see the report of what's gone on. Okay, I'll show you that in a moment. The next thing I had to do was to design a frame. So this holds the Raspberry Pi and the USB hub in a sort of solid configuration. So we just got the one mains plug coming out. And here you can see this in its frame. This is the black disk. This is before we labeled it. So here's the black disk. John looks after the black disk. This is the red disk, which I look after. And you see they've both got their Basingstoke makerspace asset IDs on. So here's the appliance in action. This is not exciting. You see the appliance over there. Here's me plugging the red disk. I plug the USB into the USB hub, and it goes chunk, chunk, chunk. It recognizes the fact that the disk is there, and it lights the light to say, "Yep, we're running a backup." And a little while later,
what is that little while?
Oh, I'll show you in a moment. The answer is it depends on how long it's been since you last did a backup, because it's an incremental backup, of course. So this is running at 4 times speed, but you'll see a little while later the light will go off and it'll indicate yes, the backup is complete, and I come along and some while after that, when I could be bothered, I'll come and, here we go, remove the hard disk. Not exciting. Okay, the other thing I've done here is I went back to my laptop and I typed the command for manually setting the error light, so you can see what it looks like when the error light goes on. So can you see the error light? You can see the reflection down here. It actually shows quite nicely through the little window there, and that's just testing that the error light works. Okay, and all of the files for the whole of the project are basically being put onto the shared files under the project backup. Okay, your question was, what is the little while later? If I go to 192.168.186.49, here's the log of the backups that we've done recently. You'll notice the top 2 ones we did tonight. Both of them took 5 minutes because they're both relatively up to date. If you have a look at the one that John did on the 25th of March, you will notice that started at 1921 and it finished at 10:49 the following morning. That was a relatively big backup. Provided you, I mean, it's incremental, so and it's fairly fast because it goes through the wires across the network. So provided you back up relatively frequently. The reason why John's took so long is because I decided to back up another disk, and when John plugged his in, it had to back up that whole other disk. That's why it took 11 hours.
How big are the backup disks?
These two are actually, well, you can see here, they're essentially 3 gigabyte backup disks. But we keep a track of the number of free blocks because, and they're 512 blocks. So yeah, it'll anyway. It's of that order. So 3 terabytes.
Yeah, I thought so.
Yeah, 3
Not
terabytes.
gigabytes,
Yeah,
terabytes.
sorry, I'm 3 terabytes. So the whole thing is about 1 and a bit terabytes. So my estimate of 5 terabyte disks was a bit of an overestimate. We found that out when so the black disk here was donated by Kevin, because it's one of the ones he used to back up his photographs, and he backs up his photographs a different way these days. This one I bought specially, but this is like 50 quid's worth of disk for a couple of terabyte.
So can it auto recover from an error disk if you forget to intervene when you've got an error condition? What will happen? I suppose is what
Well,
I'm asking.
the question is what the error is, right? If for example there's a problem with the disk and it fails to mount, to take an example, well, when you plug it in again, it's probably also going to fail to mount because it's probably something inherent with the format or the sectors or something. If it's that the network got interrupted, so over here you see there's a space for the error, and it'll actually tell you what the error was it encountered. As soon as it encounters an error, it'll stop at that point and put itself to the top state. Again, this is one of those things that the simple picture I put of a simple while loop is not quite right because of course it can jump out in the middle if there's an error. But it'll tell you here what the error is on the web page. So, and the idea is that we have a whole load of these disks, so that if one of them goes wrong, then we've got the other ones to look at. At the moment, we've just got the 2, but I've been optimistic and started doing labels for the other 4. So yeah, we can obviously the disks you've got, provided the disks are registered with it, then we can keep track of which disk is doing what.
You say it's an incremental backup. With the Apple incremental backup, if you look at the data on the disk itself, you can't get back to the original data very easily.
No.
On this one, can you get? If I just took that disk, plugged it into my laptop, could I read the files without?
No, it doesn't keep the intermediate states. No, it's just using rsync. So
effectively, you can take that disk, plug it into any machine, and actually read the files.
On this one, you can plug it into any PC and you can read the files. That's because this is using a FAT32 essentially. This one is using ext4,
So you need a Linux box.
so it needs to be some sort of Linux box. But I mean, we're not short of Linux boxes.
No. It was just the Apple one. If it gets corrupted, it's very difficult to get the data back off it.
Yeah, no, this is. I mean, as I said, when I was doing the original testing, I was doing it on the black one, and I was looking on the laptop here to see what the data was doing. So
It's much better.
How do you validate the segments in the rsync backup, the incremental backup, to guarantee you've got continuous continuous backups? Because that's a known problem in rsync.
I just assume rsync's going to work okay.
Okay.
Is the restoration process as simple as this?
Well, the rest. So what these discs have got on them is a complete dump of what's on the shared drive. In fact, it's the whole Ephesus system. So it's not just what's on the shared drive; it's the web pages and that Ephesus has got and all those other things as well. So yeah, we could restore these fairly simply. If we needed to restore this onto another Linux, I mean Ephesus is a Linux machine, then it'd be fairly easy. You need to obviously you need to be a bit clever because the operating system would be a different version. So you need to only restore the bits that are changed from because they're ours. Yeah, the shared drive, the web pages, the various cron tabs, and all those things.
So have you tried a restore yet?
No, but I have read all the data off of this one,
You have, yes.
and it looks to be okay.
You said that you didn't need a PSU for this because it was powered by the system itself. Is that right?
Yes, because
But this one isn't. This one's
No.
got its own PSU.
yes. So my original thought was that we'd only get these types of discs,
Yeah.
but Kevin offered this one for free, and it's like free one with a power supply.
Okay.
Go on, we'll go for it.
Okay, and the operating system is on the SD card. Yes? No? No?
This Linux doesn't. I
Have a
mean,
look.
in this case, the operating system is on the SD card.
Right.
In Ephesus's case, no, it isn't because it's not a Linux. It's a Linux box, but it's not a SD-based Linux box because
Okay.
it's a NUC because it's an Intel NUC.
Yep.
So the operating system is in the file system. So in Linux in general, the operating system's in the file system, and we're backing up the whole of the file system here.
Yeah, okay. All right, so if the SD card is corrupt, have you got a replacement?
No, but I mean, what I would, if the SD card gets corrupted, I would grab a brand new SD card, put a latest version of Linux rather than the old version,
Okay.
and then incrementally get the bits off of here that I need. Now, if you want to know how to do that, there's a document on the shared drive which explains how to build Ephesus.
Okay.
How to build all the components of Ephesus. If anybody wants to have a look at that, then I'd be happy to discuss it with them. Great. So that's my thing on the backup appliance. Thank you.